today we're going to have a look at how we can represent patterns and how we can represent relationships between numbers. Whoopsie daisies. So one of the ways that we can do this is through flow diagrams. Okay, now you either love flow diagrams or you hate flow diagrams, but it is a way that we can represent them. It's also a very useful way to understand relationships and is going to be a very useful way to start to understand equations when we eventually get to our equation section. So being able to work with a flow diagram is quite important, and it's going to be applicable, or it's going to be helpful in not just patterns, but also our equation sections when we get there. I can't speak English today. I don't know what's happened. The last like 2 or 3 hours of my day, the English has really deteriorated. So bear with me, I'll do my best. All right, guys. So if we have a look at our flow diagram, first things first is we need to actually understand what a flow diagram is telling us. So I almost imagine a flow diagram like a number machine. I am putting something into my machine. A whole bunch of operations is happening to those numbers or to my inputs, and I'm getting some sort of output. And so this is sort of the first bit of terminology that we need to know when we get to patterns, whereby we've got input values. So you can see that all of these numbers are being put into my machine. Some sort of relationship or some sort of rule is applied to my numbers. Whoops. And once that rule is applied, my machine spits out an answer, which we call our output. All right, so this is essentially what a flow diagram does. It allows us to apply a rule to a certain set of numbers. Now, we need to be able to obviously understand what's happening here. So this flow diagram is telling me to take my input number, add 4 to it, and then whatever that answer is, I want to times it by 2. So let's have a look at our first input number. Our first input number is -3. So we want to say -3 plus 4, because that's the first operation that I need to do. And -3 plus 4 is +1. And then we want to take that +1 and times it by 2. And we know that 1 times 2 is 2. And so we get our output number when we follow this input from -3, we get our output number of +2. All right, so by applying our rule, we've been able to get an output. I'm just going to stop there because once again, guys, please remember, like Yolanda said, we need to be listening to what's happening here. Unfortunately, you're not going to learn too much if you just do whatever you want. So you need to listen to my explanation. When I ask you to give it a try, then by all means give it a try, but we've just started. So we're doing this together and we're working through this together. Sibukazi, yes, exactly. It's telling us, or rather we do, to the numbers on the left exactly what the blocks are telling me to do in the middle. And sometimes, like you said, there'll be 1 block, 2 blocks, sometimes there'll be 3 blocks. We apply that rule in the middle. Good, well done. All right, guys, so that was our input of -3. Let's have a look at our next input. We've got -1. We're applying the same rule though. So if we look at our second input, we are going to say -1 plus 4, because that's what the first block tells me to do, like Sibukazi said. And we get a sum of +3. And then if I continue along and apply the next block, it tells me to take my 3 and multiply it by 2. And so I get a final output answer of 6. And so when my input is 1, my output is 6. And that's essentially what our flow diagram is telling us to do. So what I would like you guys to try, and this is now where we can start trying and start putting answers on the chat. I want you guys to work out what the output would be if your input is now 0. So apply the rule in the middle to the value 0. Remember, we put our answers on the chat. I've got the chat open. I can see your answers. I want to see your answers. So give it a try and see what output you get there. Well done, grade 8.
Well done, my people. Nice job. Wow. Well done.
Excellent. So if we take our input, and we say 0 plus 4, we get 4. And then we still have to times that by 2. And so we get that final output of 8. Very nicely done. Right, so because we're on a roll, I want you to try for me the last output, which is taking an input of 4 and applying our rule. So tell me what we'll get there. Nice, guys. So again, if we take our input of positive 4 and we add 4, we're going to get 8. And then we say 8 times 2, which we know gives us 16. And so our final output here is 16. All right.
Well done, my people.
Very nice, guys. Well done. So what we need to bear in mind is that a flow diagram allows us to be able to apply a rule to our input values or the numbers that we're starting with to get some sort of answer. Now, when we start to talk more and more about specifics and number patterns, okay, I will not carry on until we calm down in the chat. So take a second, stop the nonsense. When you've stopped, I will carry on. Guys, unfortunately, you distracting each other doesn't do anything. Remember, I've said to you before, if you're going to serve as a distraction to yourself and others, we'll just remove you from the class. It's really just that simple. Okay, there's lots of people here who want to learn, and you being selfish doesn't help. Okay, right. So what we need to know as well is the fact that when we start to talk about rules a little bit more formally, and we are going to do that in our next few lessons, our input can sometimes be represented with an X and our output with a Y. Now, if anyone has done graphs before, this might be familiar to you, working with these X's and Y's. And when we start to look at tables, we're going to start using these X's and Y's. So anytime with patterns or with graphs, you see an X, we're talking about an input. And anytime you see a Y, we're talking about an output. And this is going to help us eventually start to write out a rule algebraically or write out a mathematical rule to describe our relationship. All right, so I'm just going to wait there for a second for everyone to take a screenshot before I go to the next example. And the next example, you guys are going to try by yourselves. So I'll put some letters at your outputs. And remember that when you put your answers in the chat, you must number your answers correctly. So that when we see your answer come through on the chat, we know which answer you are giving. Okay, so you're taking screenshots. Alrighty, so let's have a look. Well, you're going to have a look at this one. We've got 4 outputs, so let's call this output A, B, C, and D. So on the chat, I want answers from you for A, B, C, and D. Apply the rule that's expressed there in the blocks and get those outputs for me. Remember to number your answers so that we know what's what. Okay, guys, remember, I do wait for you to take screenshots, so please make sure you do. I'm quickly going back here, take your screenshots. Right, if you still haven't got it, I will come back to it later. Be very, very careful of your signs. Remember to think about what happens when you times a negative by a positive. And remember what then happens when you start to add or subtract values from a positive or a negative value. If you need a bit of assistance, you can put a number line up for yourself. And just for those of you maybe struggling a little bit, I'm going to put a number line up at the bottom here. Just hopefully that'll help. Just so that when you add and subtract your values, you hopefully do it correctly. Okay, guys, we know with load shedding as well, there's a lot of network problems for some people. We understand. Remember, like Yolanda said, everything is recorded. So if you join late or get cut off or have to leave early, you can get the recording on Watobe's website or on the app. Melo, well done putting those answers so nicely for us.
Remember, my people, when we are marking, you are marking it because you have written first on your book, because now you won't remember what you've written, right? So make sure that you first write it on your book like this when we're correcting it with Teacher Sam. Therefore, you can mark your own work. Okay, my people?
Okay, I'm going to give everyone another minute or so, and then we'll have a look. All right, remember guys, hands only when I say so. If you've got questions, put them on the chat or wait until we do questions. Alrighty, grade 8, hands up. Would anyone like to help me with the first one, which is an input of -2? Oops, hang on, sorry. Right, Jacinta?
Ma'am.
Hi.
Hi, ma'am. Number 1, I say -2 times 3, it gives me -6. And then I say -6 minus 1 give me -7.
Excellent, well done. So guys, I just want to stop at this one because quite a few of you said -5 or 5, and we just need to be clear why it is not. So like Jacinta said, for the first one, we are saying -2 times +3. A negative times a positive is a -6. And then if we go to our number line, here we are at -6. We want to subtract 1. I actually haven't made my number line big enough. So when we go and subtract 1, we are now moving to the left. So taking 1 away is going to take me to -7. We are not adding 1, we are subtracting 1. And so we end up at -7. Very nicely done. Mvuyo, do you want to help me with B?
Yes, ma'am.
Okay.
B is equals to -4.
Excellent. Well done. So guys, again, -1 times +3 is -3. So there I am, -3 on my number line. I want to subtract 1. So exactly as Mvuyo said, we end up at -4. So please, please be careful of your signs. Okay, where we often make silly mistakes is our signs. Itumeleng, do you want to help me? Where we see? There should be a pop-up to unmute yourself. Maybe I need to ask you to unmute. Oh, gosh.
Yes. The answer is equals to 2.
Okay, I'm not too sure what happened. My screen just went weird. Okay, cool. So 1 times 3 is 3, minus 1 is 2.
Equals to
Perfect.
2.
Perfect. Well done. Okay, Retu, do you want to help me with the last one?
Yep.
Okay. What's the last
So,
one?
3 times 3 is equals to 9. Then 9 minus 1 is equals to 8. So the answer is
Perfect.
8.
Excellent. Well done. So guys, again, 3 times 3 is 9. 9 minus 1 is 8. All right. So make sure you are following your operations correctly. Make sure that you are taking very careful note of your signs. Like I say, often where we go wrong in maths is a silly sign that we've forgotten to change or changed incorrectly somewhere. And so always double check that your signs are correct. All right, I want everyone to lower their hands. I'm going to wait here for you to take a screenshot. And while everyone's taking a screenshot, let me just lower everyone's hands. Right, while everyone is taking a screenshot, if you have questions, now is the time to raise your hand. And remember, guys, you can always put questions on the chat if you need. So, Malene, what is your question?
Ma'am, can I ask? On integers, when the signs are the same, don't we add?
Give me an example. Excuse me.
Ma'am, here, because since it says -1 multiplied by 3, -1, don't we have to add the 2 signs of the negative?
Okay, so we only do that if we're multiplying. So if this had been times -3 in the block, then when we say -1 times -3, then we will end up with a +3. So it's only when we're multiplying two negatives. But here, because I had a positive and a negative, I keep the negative.
Okay.
Okay, good, well done. Guys, also just on that whole sign thing, also remember that if you've got something like 6 minus a -1, this is also what we're talking about here. These two negatives are technically being multiplied together, and so it becomes 6 plus 1. But if you have got a situation of -3 minus 1, there's not a double sign, so it stays negative and becomes -4. So always just be careful with those signs as you go along. Do you still question?
Ma'am, my question is, if we times by the first one, -2 times 3, it's -6, right? So when we minus 1, it doesn't go down, it goes higher, right? Because it's a negative.
It depends what you mean by it doesn't go down. So it technically is going down. It's going down towards negative infinity, but it's becoming a bigger negative.
Oh, okay.
Okay. So guys, again,
Yes.
like an important distinction to make. We're at -6 and we're taking away 1. So we're becoming more negative, which means that the negative number is getting bigger. All right. So just remember that. Please also, let's just remember to mute ourselves once we have asked our questions and to lower our hands once we've asked our questions. Okay, if we times it, okay, your lens is on it. I don't know why I stressed. Right, guys, I hope you've got your screenshots. Let's do one more before we take a brain break. So now we've got 3 blocks here. I'm going to do the first one with you, and then you're going to try by yourselves. So if we have a look at our first input, so remember our inputs all here on the left-hand side, this is represented or can be represented with an X. All right, so if we now take our first input of -5, so the rule says we must add 1, times by 3, and then divide by 2. Okay, so we've got -5 plus 1. If we just jump up to this number line, here I am at -5. I'm adding 1, so I'm moving right. So adding 1 takes me to -4. So I've done my first block. Now I need to take my -4 and I need to times it by +3. A negative times a positive is a negative, and 4 times 3 is 12. So I've done my second block. Now I want to divide that by 2. So I take my -12 and I want to divide by a +2. A negative divided by a positive is a negative, and 12 divided by 2 is 6. So now I've worked out that my first output, when my input is -5, is -6. All right, so nothing changes. Just because we've got more blocks doesn't all of a sudden mean that something changes. We still apply our rule and we go step by step in order to get our output. So I want you guys to finish it off for me and find the outputs for 0, 3, and 7. I'll add some numbers here. So let's call this A, B, and C. So I want those outputs there.
Let's go, my people. So remember, you need to listen, right? Listen, my people. You need to give us A equals 2, B equals 2, C equals 2. So far, I haven't seen anything. And so far, I regard whatever that you told us on the group wrong. Why? Because you need to give us all 3, my people. So don't be in a rush. Write it, all of them, on your book. And then come here and say A equals to this, B equals to this, C equals to this, all 3. Thank you, Lisake. Well done for listening to instruction. So far, only Lisake has given a possible answers. I'm not saying that they are correct. I'm not saying that they are wrong, but it's at least in the way that we should give, okay? A equals to, B equals to, C equals to. The rest of you who are giving A, and then suddenly your name come up, you're giving C. I don't see anything. I don't see anything. You need to write every single answer on your book first so that you'll be able to correct them, okay? Because when you're writing it in the chat and your answer is wrong, by the time we are correcting the teacher Sam, you don't remember what you wrote. So you need to write it on your book first, then write it on the chat by giving us all 3 answers. And all the hands that are up now, you should bring them down because we want all your answers on the chat. Okay, my people.
Guys, so just with the hands thing, remember, if you have a question, you can put it in the chat, right? We don't do hands in between because otherwise we just get too distracted. So if you've got a question, put your question in the chat or send it to Yolanda or myself and we'll help you. But otherwise you wait until there's question time, and I've already said to you that B will be a fraction. So please don't ask that question again. I've now said it twice.
Thank you, Bokamoso, for giving those answers. Give it as a fraction, my people. Like this, you don't have to worry about remainders. Uratile, put your hand down. I won't be tired to remind you, my people, so you'll hear my voice and it will annoy you. Because I'll just keep on reminding you. Edwin, we need A, B also. Thank you, Zoe. Let's go, my people. We are 131 of us. So, of course, it's going to take time. Tumelo, thank you. Sia, thank you. Jabulo, thank you. I'm not saying your answers are right. I am saying thank you for putting it in the format that Sam has instructed you to do so. Sipo, thank you. Zuna, thank you. Ayo, thanks. Zubuya, thank you. Okay, so majority of us, yes. Now majority of us have put it in there, Teacher Sam.
All right, guys. So if anyone wants to raise their hand to help answer, you can. I'm going to do my best to try and give everyone a chance in terms of hands. Excuse me. All right, Lexa, help me out.
In the part that says A, I said 0 plus 1, which was 1.
Mm-hmm.
Then said 1 times 3, which was 3.
Mm-hmm.
Then divided it by 2, which gave me 1.5.
Perfect. So guys, for the first one, exactly as been explained, our answer is 3/2, or you can write this as 1.5. I don't really mind. And there's a bunch of different ways we can write 1.5. So I don't really mind which sort of format you put it in. I personally prefer the fraction format of 3/2. That's my personal preference. But any of those are absolutely fine. So we try and avoid remainders, just because like from grade 8 we don't really work with remainders. If you do still work with remainders at school, that's obviously absolutely fine. So if you've got one remainder 1, cool, but mathematically our answer is 1.5. All right. Oh golly, sorry. Let's get this. Akona, do you want to help me with B? Yes, we can hear you.
Okay, for B, I said 3 plus 1 gave me 4.
Good.
4 times 3 gave me 12.
Good.
12 gave me 3.
Perfect. Okay, so guys, B was quite similar to the first one we did together, except now we got a +6 instead of a -6. Very nicely done, Akona. Well done. Alrighty, we got so many hands. This is awesome. Oratile, last one for me.
Hi, ma'am.
Hi.
So I said 7 plus 1 equals 8. 8
Good.
times 3 is 24, and 24 divided by 2 equals 12.
Perfect. So just in case none of you or some of you didn't hear that, 7 plus 1 is 8. 8 times 3 is 24. We should know that from our maths, 24. And then 24 divided by 2 is 12. So our output there is 12. Right, so even though we had 3 blocks, even though we had 3 separate operations that we needed to do, didn't change what we sort of the steps or the method that we needed to follow. We still just apply our operations according to what was given to us. Alrighty, so let me make this a touch smaller. If you want to take a screenshot, take your screenshots. And then we're going to have a little bit of a break.
Well done, guys. Y'all deserve a break. And for some of you who wants to answer, look, because there's so many of us, okay, so Teacher Sam is just randomly choosing those ones that we haven't talked to. I promise you, she loves you so much as I do, and would really love to hear everybody's voices. But because we're a lot, we can't, right? So Amanda, I can see you, like, can I do D? So normally you just raise your hand because Teacher Sam says you can raise your hand. And then you wait. Sometimes we can pick your name, sometimes we can't, but you already written your answers down and you are marking them as we are all marking our answers, okay? So we do recognize you, we do see you, and we love all of you equally so.
And guys, I do try every week to pick different people. I do my best, okay? I don't know why there's hands, but okay. Wandisile? Okay, Fortunate question?
No, ma'am. I'm sorry.
Yeah.
I just raised my hand when we were doing this, so I
Oh,
I
okay.
don't, I'm just new.
Sorry?
I'm just new. I don't, it was a mistake.
Okay, don't worry. I'll lower it for you.
Okay.
Okay, guys, I haven't actually asked for questions, so I'm not entirely sure why we have so many hands. Remember, you put your questions on the chats. Unfortunately, it means if I have to go through questions, then it does mean we just don't get a brain break. Nelson, I did see your hand up earlier. Have you got a question?
Yes, ma'am. I just wanted to ask, couldn't the answer of A be 1 remainder 1?
You can, yeah.
Okay, thank you, ma'am.
Pleasure. Watermelon?
Hi, ma'am.
Hi.
I wanted to ask if the input is a negative, so do we plus it and get a negative answer also?
It depends on the rule. It can be anything. So in this one, it just so happens that I said +1 and we still ended up with a negative. But if I'd said, say, for example, times -3, then a negative times a negative is a positive. So it really just depends on what the rule is. Okay, so it can be different each time. It just depends on what rule we're applying.
Okay, ma'am, thank you.
Okay. Okay, guys, questions? It's okay. Amanda? You just need to unmute yourself.
Ma'am,
Yeah.
for D, isn't it 7 + 1 equals 8 multiplied by 3 equals 24 divided by 2, and the answer is 12.
Yep, that's what we've got there, 12.
Oh, thank you.
Sure. Okay, Boytu again.
Ma'am, I just realized that on A, we said an input, the input is -5. So is it always we get a half number or a fraction number?
It depends on what the rule is. Depends on what the rule is, and it depends on what the input number is.
Okay,
So
ma'am,
sometimes we will, sometimes we won't.
Okay, ma'am. So is it possible if, like, on our exams, they can give us a big negative number, then we can get the half?
Yeah. So yeah, it just depends on what they give you.
Okay, ma'am. Thank you.
Sure. You guys want to know why there's no break? Because no one listens when I ask and don't ask for hands. That's why. Akani? There we go. Nope. Okay. Emmanuel?
Akani, sorry, Akani, you can talk. Akani is unmuted. Akani, you can ask your question. You
No,
just have
ma'am,
to talk.
No, ma'am, I pressed it by mistake. I wanted to go to the chat. And
Okay. Oh, okay. No worries.
Yes.
Hello,
No
ma'am.
worries.
Hello, ma'am.
Yeah?
Yes, ma'am. Ma'am, I was asking, if they can give us what you call a negative number, is it possible to change it into a fraction? Even doesn't matter how big the number is.
It doesn't really matter. The only way we can get it as a fraction is if we divide by a number that's then bigger than it. So if you had like -7, if I then divide it by something that can't divide into 7, then I'll get a fraction. So again, it really just depends on what the rule is.
Okay, thank you, ma'am.
Okay. Right, I'm stopping, I'm moving on. So let's have a look here at this next example. Another way that we need to be able to deal with patterns is to also use a table. And now this is where our input and output values come into use again. Now again, if anyone has questions still, you need to either direct message Yolanda or myself, or you need to put it on the group. Unfortunately, we just do not have time to spend, we've spent almost 15 minutes on questions. Otherwise, we're just not going to do the work. All right, simple as that. Right, so if we've got a table here, we've again got inputs and we've got outputs. The only difference with our flow diagram and a table is that I'm not giving you the rule. So what we need to do is very similar like what we did in our first lesson, is we need to figure out what the pattern is. So if we have a look, we are going from an output of, or yeah, we're going from an output of 3 to an output of 2. So if we think about what we're doing there, we're subtracting 1. I'm then going from an output of 2 to an output of 1. Again, I'm subtracting 1. And then I'm going from an output of 1 to an output of 0. Again, I'm subtracting 1. So what I see, and in answer to this question of describe the pattern above in words, is we subtract 1 each time. Okay, so that then means we can continue our pattern. If we say 0 minus 1, we get a negative 1. If I say negative 1 minus 1, I get a negative 2. And if I keep going, I can continue my pattern basically for as long as I want. All right. So in looking at our pattern, we have been able to describe our pattern in words, and we have found the output values for these input values we filled in our table. Excuse me. Right, I'm going to, no, sorry, my words got mixed up there. So we have filled in our table, we've described our pattern, and now what we want to do is we want to sort of try and describe a rule. So whenever in a table you see this last block, and sometimes it's another letter, but sometimes we've got this last block with our input of X. What we want to do is we want to describe the rule here. Now, remember, if you think back to your flow diagram, we always start with our input. We apply some rule to our input. We don't know what that rule is. We might be adding stuff, subtracting stuff, dividing stuff, and we get an output. And this rule must apply to all of the inputs and outputs I've given you in the table here. Okay, now a good place to start is always with what you are adding or subtracting. So in this case, we're subtracting 1. Now remember, we want to go from the X, from the input, and get to the Y. So what I want to do is I want to look at all of my inputs here and try and get a rule that will get me to each of the outputs for each input that I have been given. So if we start with the minus 1, if we say input of 1 minus 1, that gives me 0. It's not giving me 3. So I'm going to have to think of something else here. Now the key or the trick or the rule, whatever you want to call it, is whenever we've got the same thing that we're adding or subtracting each time, that is generally what we're going to start by multiplying X by. So if I think about my flow diagram, my first block is going to be times negative 1. Okay. So if I think about, let's take our input of 1 and I say positive 1 times negative 1, I end up with negative 1. But I know that I want to get an output of 3. So I now need to ask myself, how do I get from negative 1 to an output of 3? Well, I know that I can add 4. So let's see if we add a second block of plus 4, if this now applies to all of my inputs and outputs. So let's go to our second input. Our second input is 2. So let's apply our rule. 2 times negative 1 is negative 2. Plus 4 is 2. So that rule works for my for that input. If I go to my third input, so we're working with 3 now. 3 times negative 1 is negative 3. Plus 4 is 1. So what I see is that just by trying to figure out what I'm multiplying, what I'm adding, what I'm subtracting, I've been able to find my number machine rule that applies to this table. Okay, so now you can see in question C, it's asking us to draw a flow diagram. So we're not going to use all of these input values because that's going to take too long. But let's say I took my input value of 1, 4, and then we'll put X at the end because that's quite useful for us. We know that all of these values have to go into our number machine. The first thing that needs to happen to them is that we need to times them by negative 1. And then we have to add 4. And that gives me my outputs of 3, of 0, And then when we get to x, this is now where we can start to describe a rule. Right, now if you are unsure about the rule or the blocks that you're going to fill in for your flow diagram, you can always go and double check yourself. And that's exactly what I was doing here. If you take each of your input values, so each of these x values, and you apply the rule that you've come up with, you should always get the corresponding y. And because we kept getting the correct y value or the correct output value, we knew that our rule was correct. So now when we want to try and just like put this x value, so here we are at our flow diagram. If I now want to put this x value into my flow diagram, I need to times it by -1, and I need to add 4. So this is now taking us back to algebra. If we have x and we multiply that by -1, we know that a positive times a negative is a negative, and 1 times x is 1x, or you can just write x. Then we want to add 4. Now those aren't like terms, so I can't do anything with that. I leave it like that. And so what we've discovered is that the output value is -x plus 4. And this is now where we get to this idea of an algebraic rule. So you can see here in question D, we can now write down an algebraic rule, because what we found is that that output value, that y value, can be found by taking any input value, and we represent that with x, and adding 4 to it. And so now what we have is a rule that we can apply to any input value. So write that down. And so now what I could do is I could say, Now what I could say is I could say find the output value when your input value is 7 or 10 or 50. And all you would do is replace the input. So replace the x with what I'm giving you. So if I said your input value, so your x value is equal to 20, you could now substitute in. So you could say y is equal to -20 plus 4. And you can get the corresponding output value for that input. Once you have a rule, you can get any output value that you want. Right, so I know that was a fair amount of information. So what I'm going to do is I'm going to make that a bit smaller so that you can take a screenshot. Whoopsie daisies. There was a question of how do we get y if there's 2 x's? Well, firstly, there aren't 2 x's, there's only 1. And secondly, remember, all of these values over here are your outputs. And outputs are represented by y. So all of these values represent a y. So we're saying y equals 3, y equals 0, y equals -x plus 4. So it's basically just us writing out a rule that describes whatever the pattern is that we have. Right, again, I know that was a lot of information. So if you have questions, now's the time to raise your hand. Tatenda?
Hello, ma'am. Ma'am, I wanted to ask, ma'am, what is the difference between the term number and the output number?
Okay, so the term number is basically your input. So your input is the term number. What that means is it is the first term, the second term, the third term, the fourth term, and so you keep going up in ones. The output is then the value of a specific term. So the value of term 4 is 0. So that's the difference between the two.
Okay, thank you.
Sure. Just quickly on the chat, I have no clue what the curtain method is. I've never heard of that. Maybe in the next lesson, you'll need to explain it to me, but as long as you're getting the same answer, I'm sure it's fine. But maybe in the next lesson, I'm going to ask that you explain it. Right, guys, you'll see that your quiz link is there on the chat. Remember, today is Wednesday. we need to do our quiz. So I hope I say your name correctly. Zanera, please just remember to explain it to me for next time, because I'm always interested to know new methods. So please try remember. Right, I'm taking one more question, and then unfortunately we do need to go. Gideon. Hi.
So basically, numbers. If we, for example, we didn't get like what number we must like add or minus whatever to get output, can you just use like your any variable was.
I don't quite know what you mean. Say it again for me.
But for example, numbers like they given an equation was, but like they did any variable or any number. So must I start with the variable first to get to my number was.
You would start with your variable, yes, but if we want you to come up with a rule, we would have to give you some of the values so that you can see what the pattern is.
Oh, okay, Miss. Thank you, Miss.
Okay. So we'll have to give you something if I expect you to find the rule.